So today's going to be a little shorter. It's going to be just looking at reactions of acids and bases. So here we go. So when you have an acid reacting with a metal, we've done this before in lab, you get hydrogen gas produced, and then you get the salt with that's made from the anion of the acid with the metal. So the metal is replacing hydrogen in a single replacement reaction. It's forming H2 because of Hofbrinkel, and then balancing the charge, we get zinc chloride. The metal has to be fairly reactive to do this. So all of the alkali metals, the alkaline earth metals, and then reactive metals like aluminum and zinc will do this. Other metals that aren't very reactive, like the coinage metals, copper, silver, gold, they will not react with acid like the other reactive metals. They will not be able to replace hydrogen like this. So this has to be a fairly reactive metal in order to get hydrogen gas. Also, acids will react with carbonates or bicarbonates. So hydrogen carbonate is a bicarbonate, and we all know baking soda and vinegar. The one on here is hydrochloric acid with potassium carbonate. All of those, it's a double replacement reaction. The H and the cation of the other substance, the H of the acid and the cation of the other substance are going to switch places. And let's have my pen. And so we get first, when they switch places, we get H2CO3, because again, you have to balance charges, carbonates -2, so you need 2 hydrogens, and then the K goes with the Cl, Cl is -1, K is +1. So the thing about H2CO3, it's called carbonic acid, it immediately breaks down to form CO2 and water. So that's why when you mix an acid with a carbonate, you will see bubbles of carbon dioxide gas immediately produced. And then the other ionic compound is just your salt. Okay, so that's with acids with carbonates or bicarbonates. You get bubbles of carbon dioxide and water and a salt. Then a neutralization reaction is anytime you mix a hydroxide with an acid. So sodium hydroxide plus HCl is our classic, and we get water and salt. But the same with, if we have a different strong acid, potassium hydroxide with a strong base, potassium hydroxide with a strong acid, hydrobromic acid, we still get water and a salt. It's just any ionic compound is called a salt. So the H and the OH get together to make water. Remember, we'll think of water as HOH, and then we get the salt. So that's neutralization. So what would be the balanced equation for the reaction of HCl with BaOH2? So HCl plus BaOH2. So of the three, this has to be a neutralization reaction. So the H from the acid is going to get together with OH from the base to make water, which is HOH. And then the Ba, which is +2 charge, is getting together with the Cl, which is -1 charge. So we need a 2 here. So then we would need to balance our equation overall. We come back over here, we put a 2, and we come over here and put a 2. So then we have 4 hydrogens in both, 2 chlorines in both, 2 oxygens in both, and 1 barium in both. If we were going to then write the net ionic equation, if this is, well, first we'll do the complete ionic. So this would be 2H plus 2Cl minus. Barium hydroxide if it's a solution, would be split up into Ba plus 2 OH minus, and then we get water. And then barium chloride is soluble, so we get Ba plus 2 Cl minus. And then as we look to see, we are going to cancel off the 2 Cl minuses on both sides and the Ba plus 2 on both sides. So what we're going to have left is H plus OH minus makes water. And this is the net ionic equation for all strong acid, strong base reactions. It's always just H plus OH minus makes water. We could have just written that right at the beginning and been done. Okay, so then for the next one, write the balanced equation for magnesium with hydrochloric acid. So magnesium plus HCl. The magnesium is going to be a single replacement, kicking out the hydrogen and stealing the chlorine, but magnesium is plus 2. And with Hofbrinkel, we need H2. So we put a 2. So that's the molecular equation to write the complete ionic. The HCl, again, is split up, and magnesium chloride is soluble. So then our Cl minuses cancel. So we end up with Mg plus 2H plus goes to Mg plus 2 plus H2. And here's my joke. Did someone mix your acid with a base because you're a bit salty today?